So let me check, for example, in Trivandrum. Now you are all here. Say, for example, Cavita. Cavita. Oh, you changed that. Okay. Because yesterday there was a yes here.
Yeah.
And all of this was no's. And I didn't understand. Because when you put a yes here,
Yeah.
that you want me to check, but I checked, but actually what you put here it was correct. There were some no's here. So you have to put here a no until you are finished.
Okay. Okay.
Okay? But anyway, I will check it today because yesterday I shared with you my plan.
Yeah.
This is my plan. Okay?
Yeah.
So today is 8th of March. So this is what I'm going to do today. I'm going to do week 5. So you should also try to do week 5 or finish week 5 today, because today I'm going to go back here and check all of this. This is like Yasil, you see? Yasil has a yes here, he has a no here, because it has some no's here. Like this. So today, I'm going to revisit this for you, Kavita, and for if Yasil or Rashid had something missing. So he has to explain what happened to the clock and show how did the design explain with words. Is Rashid there?
Yeah. Rashid. He wants to give you feedback.
Hi, Rashid. Rashid.
Yeah.
See your page. Your review yesterday, and it's all fine. You did a lot of work, but you are starting to be one-liner here. Okay, many pictures, but very little explanation. So in here, please, did you design all of this?
Yeah.
So you should explain about the process, because it's, you see, it's a very complex thing. So this is nothing you do in little time. So you should explain how to do at least some of this. Like, you don't explain anything here. Okay. Looks like you are doing magic. You should explain a little bit, and then you see this. It didn't print what you design. So this is not the same as this. So you have to say something about what happened. Because this is 3D printing week. You have to say, up to here looks correct. And then you have to explain what happened here with text. Okay? So say someone comes with this design for you to print, and you give him this. He's gonna tell you, I'm gonna pay for this. So you have to write something here. And this something is that the printer cannot print on air. It's a support material. So this is not a good design for making it in one go. Maybe you need to split this into parts, at least these two bells. It won't print in one go, like you want to. I wonder how these lower parts are also printed, because they look like very flat at the beginning. So this is the things that you have to show. How is these parts, and how are the parts that were difficult to print? So, Rajit, also, this thing you are showing here, it's a single mesh. But I mean, and this is the patched mesh. But what is the blend file is here. Do I have Blender anyway? No. So I tell you something, Rashid. The way you have put the way you have put this design, your global evaluator is going to think you have not done this design, because what you are showing here is the patched mesh, not the original. You see, when you click here, you are selecting the whole mesh. But you didn't do this like this. You did it like individual parts, like it was a cylinder, this sphere was a sphere, less another sphere. They will want to know how you did these things here. All of this, they will want to know. If you have done this, they will want you to explain how you did this. Because it's important, because it must be your own design. So you have to explain like this also. This is why you have no here. It says show how. It says show how here. Show how. There are some other people like they don't have this because their design is very evident that you did a very complex design. Then in here, you didn't outline the problems and how to fix them. So in here, this printed apparently well, so no problems apparently, but this, it has problems. So you didn't outline these problems and how to solve them. And this is what you are missing here. Okay? So this is what you have to do. It's today, you will have the result today as well. That's it. Are you talking, Rajit? I cannot hear you.
Yeah, I can.
Rajit, are you saying something? Very, very far away.
Can you hear? Frank,
Now much better. Yes.
can you hear now?
Yeah. Now, and the audio is. Yeah,
Audio
much
is?
better.
Okay.
Much better quality.
I think there's some problem with the internet. I mean, it's lagging.
No, it was a problem with the microphone. You select like the microphone.
No, I mean, we have problem with hearing you.
In my side, you mean? Oh, yeah, because okay. Check the Blender file of Rajit, and I am installing Blender now at the same time. So let me
Okay, maybe that way.
post this.
ഞാനവിടെ ബ്ലെൻഡർ ഇൻസ്റ്റാൾ ചെയ്യുന്നുണ്ട് നെറ്റ് വലിച്ചാൽ കിട്ടുന്നത് അങ്ങോട്ട്
Kernel file. Okay. Then in the
എന്ത്
oh,
നോക്കോ എന്ത് തലി കിട്ടി
you know what happened with Kochi?
No.
Huh? Yadu?
Not from Kochi, I think.
Yadu?
Yeah. Can you hear?
Yeah. Yes.
What do you ask? I didn't hear. What did you
Yes.
ask?
Kochi. What happens with Kochi?
Uh, Actually, I don't know. Only Atif and Daniel there, but no idea where they are.
Can someone give them a local call
Okay.
to see what happens?
Okay.
Because only Riya see.
Yeah, I will call.
And Yogi,
Yeah.
Yogi,
Yes.
why are you leaving your
Sorry. Yeah. Go ahead.
why are you late in your grades?
I just came back yesterday, so yeah, I've started working on it yesterday. I've pushed a little bit of content, but I'll finish it off today and tomorrow. It'll be done.
Okay, take into account this schedule.
Sorry.
Uh, take into account this schedule I shared. Because you want to be on par with this. If you want the feedback. Okay? But many people like
The schedule is not very clear, but I'll just go through it. I guess that's in river, right? I'll go through it and check.
okay. Mm-hmm.
And in Kochi.
Okay. So
Rank in Kochi. It's power failure there in
but
Kochi.
yeah, I just read. I just read this.
Yeah.
So what you have to do now going over is going over the week, the current week. So is the regional review today? No, is not this. Is
In the back video.
so now you are disconnected. Let's see what you did for this week. So this is Neil Bohr. Okay.
That's me, right?
Yeah.
Okay. You started in Eagle. You're starting in Eagle so far.
Yeah. I've been struggling with this week. Eagle is not very user friendly. So I've been trying. I installed Eagle on Mac and I installed Eagle on Linux as well, just to compare the experience. It took me a while to understand how just to load the libraries. So now I'm currently creating the schematic. So that's where I'm at right now, and I'll be updating. I took your advice from last feedback. I'm updating the website each time I do one step.
Yeah, that is a good habit. Yeah.
Yeah, but Francisco, one question I wanted to ask, actually, it's more of a concern. So even though we've gone through the tutorials and the method of using the software is okay, but actually designing, like understanding how to tweak the design and putting the LED, putting the push button into the overall design of the circuit, that's very challenging for me. I mean, it's not easy to visualize how, where, like, how do you start from scratch? I believe Yogi is having the same, issue, but I sort of wanted to, voice my concern because it's not easy. It's not very clear how we are supposed to actually learn electronics design. Because that Neil has not given any background on that.
Yeah. Okay. As Neil said, Kavita,
Yeah.
you are not going to learn electronics design in 1 week. If you could do that, I mean, you would be multimillionaire.
I guess that's why I'm not.
Forget like about learning electronics design in 1 week. This week was more on design tools,
Right.
not and very basic circuit design. So what we have to do this week is we put an LED here.
Yeah.
Okay, so this is the very basic circuit design we have today.
Okay.
So we have a battery here, okay, and this. But because this will suck, like this is like 5 volts, this will suck all this LED here.
Right, yeah. So you need a resistor in series.
Yeah, you need a resistor. This is the very basic thing to
Yes,
learn this week.
yes,
But
yes. Okay,
and you should do the calculation.
right, yeah. Kirchhoff's laws. Yeah,
Yes. If you look into the datasheet of this component, like actually this component, I wrote it like this. Something like this. If you look in the datasheet, you have access to the inventory, doesn't you? Don't you?
yes, I do. Yeah.
But the physical inventory, do you have access to it? Like,
Yes, yes. Yes, we have access to the physical inventory.
yeah, but no, I don't mean that. I mean this. Um,
You mean the tracker sheet where you get a forward bias drop and driving current and those kind of stuff, right?
yeah, like the FabLab inventory.
Yeah, the spreadsheet, yes, we have access to that.
Yeah, in the spreadsheet, if you look to this component, if you are using the green or the yellow or the blue or whatever your LED are using, there
Yeah.
is there is a DigiKey code.
Yes, yes.
In DigiKey, you paste this code here. This is not the code, but say I paste the code here. and you will find the datasheet. And inside the datasheet, it will tell you like the typical current of this maybe is 2.5 milliamperes or 5 milliamperes, and then you have to do the calculations. And what is the resistor value you should put here?
Okay.
To have.
Yeah. So basically, you would advise that we sort of draw out the circuit, look at the different calculations, and then attempt to insert the new elements like the push button and the LED and so forth, right?
Yeah, but the circuit we are making today is this one actually.
Okay, the fabric size. Okay.
Is this one with just a button here?
You're referring to fabric size, correct? You're talking about today's fabric size?
No, I'm talking about the circuit design we are doing for this week. It's just this one, this very simple circuit. You have to understand.
Francisco, that's not the one in the assignment. It links to the Hello World circuit from the embedded systems programming page, which has the FTDI and the ISP and a capacitor, resistor, all those things. So that's where we were confused, which is if you start with that, what's the purpose of the capacitor? Why does, how do the pins, what is the purpose of each pin? Where should we, so there's a lot of background knowledge that we need to ramp up on before we can kind of build on that circuit and add a LED and switch button. So I think that's what we were stuck on. That's what Kavita was also mentioning.
But where is that?
If you go to the assignment page 2016, the link that we are taken to is the Hello World board using the 80 Tiny 44 chip. So if you get you can look at my website. I have listed all the links. Since you are on my week 6, if you can just click on my tab. Yeah. Okay.
We are here?
Yeah.
Go to the bottom.
Just go to the bottom.
Without the Echo Hello World?
Yes. That's from the embedded programming week.
Yeah.
Yeah. Is this the Hello World?
Yes.
Is this one?
Yes. This is the one I put on my web page as well.
Yeah. So what is the question? You don't need to do all of this because this is for embedded programming week. You will cover all of this.
Okay.
In the programming week.
So then.
You don't have to.
But then what, like today's assignment, I mean, this is the first time I'm hearing about the diagram that you showed. We have been working towards the assignment on the website, on the week 6 lecture. That's why the question.
I think everybody else has also done the same thing, right? You've taken the Hello World example from the embedded programming week, the Hello World FTDI, and built that, right? Yeah. So Francisco, everybody's done that, which is this Hello World with the FTDI.
Yeah, the one that you're looking at.
Yeah.
Yeah.
Yeah, but this week, I don't know if I am understanding the question well. This week is about making this circuit we see here, but using a microcontroller to open and close this button, and operate this LED.
Okay.
This is the first time I'm hearing it.
Okay.
If you have this simple circuit, do you need a microcontroller in there at all?
Okay. Actually, we are not making this circuit. We are just using a microcontroller. It has many pins that you can use, and you are hooking here one resistor and one LED that goes to ground, and here you are attaching a button that also goes to ground. And this is the design you are doing, because you will operate this circuit using software.
Right. According to the page, the the archive page, we are supposed to design the Hello FTDI from the scratch, and we are supposed to make it so that it will be ready for the programming 2 weeks from now or a week from now.
Yeah, programming will come 2 weeks from now.
Yeah, but we have to make the Hello FTDI from the scratch, and we have to make it in Modella this week. This week, that's the assignment.
Yeah, this week is to learn about design tools, placing this circuit adding this, like redrawing his board, adding these two features,
Yeah.
and fabricate this. This is the assignment for.
No, this is you have to add a button and an LED to the Hello FTDI, right? Not just simple this circuit.
Yeah, I mean, I don't want to rewrite everything, but yes, the hello. This is the hello. This is the hello FTDI. Suppose this is the hello FTDI. You have to add this.
Right. So I think we are on the same page then. So the difficulty that we are having is that, at least Kavita and me are having, is that there are a bunch of components on the Hello FTDI. For example, there's a capacitor, there is the FTDI itself, there's the microcontroller with multiple pins. So what gets connected where? How to figure that out? And that's where we're struggling. So yeah, we can ask around and we can find out from the rest of the gang, but I think understanding the concept would be useful.
And, getting the right background.
We like to explain it like why a microcontroller is connected to a IC, or why a diode is connected to a thing, why a resistor is required.
I know, so we understand those concepts. So again, we understand the concepts, like we've read through all the tutorials on capacitors, resistors and all that, so that's okay. But given these basic building blocks, how do you actually build a circuit in the way it is? Like, why do you need a capacitor first in that circuit at all? I can understand why resistor is required, but why is a capacitor required? That's one question. The second question is, in the FTDI, how much power, what's the power source, and how much voltage is available? So that's something which I was not clear on. Yeah, so questions like these, is where we're struggling.
Yeah, and just to add that, I mean, I think to an electrical engineer, a lot of this would seem very obvious because they're used to designing circuits. But maybe somebody who's not from an electrical engineering background may not understand, may not have the required knowledge, background knowledge to create their own circuits. So that's probably, we both of us are asking this question from a new person, lay person's point of view.
Okay, so when you have all of these questions, the best thing is to write these questions, and you try to solve them one by one.
Yeah.
Okay. So let's start from one from Yogi, the power source. So the power source, I mean, this is the hello board. Okay.
Yes.
And you don't understand why is this capacitor. What we have here, we have one connector, one FTDI connector. This is a connector, okay? This is this. We have one connector that goes to some pins in the microcontroller. We have another connector that goes to another pins in the microcontroller. We have a resonator here, and we have a resistor with a capacitor.
Is it a resonator or a crystal? Because in the Fab library, no, there are two entries. There's one crystal and there's one resonator.
This is a resonator.
This one is a resonator.
Okay. Okay. Thank you.
Okay. I mean, I didn't share the book. Did you have access to the book? Did you find it yourself?
Yeah, I mean, I looked at the layout diagram, I trace the names to the picture representation in the fab.lbr file and selected a bunch of components. So, for example, in the library file, I selected the Atmega 80 tiny 44 SSU. So, I mean, because it's obvious we need a chip. So I selected that. Then it's, also in the diagram, it's listed FTDI header and ISP header. So I selected that as well from the library.
Okay. So let's start from the beginning. All of the components you see here are actually optional. You don't need anything of this for making the circuit board working. Okay? So let's start why they are putting one by one these components. First of all, let me go to solve Yogi's question about the voltage. At the beginning, let's clear this. You only need this. You only need this. This is the microcontroller. And you have to think about something that you can control by software a lot of here, like a lot of switches here. Every pin is like a switch that you can control in software. Okay? This can be act as an output. It means you can control this and you can deliver either 5 volts or 0 volts.
Okay.
That you can control later in software, this switch.
Okay.
And also you can also act this as an input, meaning that if you connect this to a pin, a switch, you can read if this is a 5 volts or a 0 volts. So this is the two things that you can do in a microcontroller. Okay? So just think about this in here. You can connect an output, which is an LED, or an input, which is going to be, in this case, a button, to almost any pin. I say almost because I was going here. If you go to the assembly, this is something you need to have in your desktop, like from now forever. The data sheet of the microcontroller. And in here, it's all the information about the microcontroller. And one of the information is what a Yogi is looking at. Like, this has 238 pages. You don't read this like a book, like a novel. You don't read it like this. You just look for information. And in here, it's telling you what is the operating voltage. So, this is the voltage you can hook into the 80 tiny 44. Because we don't have the B version, I think. We have the normal version. But you have to check with a loop. You have to check with a loop what is the text written here. If it's a V, then you can do from 1.8 to 5.5. So the power source must be this one. Otherwise, the microcontroller will not work. This is one question. And
yes,
then it comes the speed. So if you want to run it to 20 megahertz, then you have further restrictions. Then the power source must be 4.5 to 5.5. Because otherwise,
what's the reasoning behind the operating voltage? I mean, are you saying that we need to select the voltage depending on the resonator? Like for example, the resonator is 20 megahertz, so the voltage has to be 2.7 to 5.5. I mean, how do you make that decision?
Yeah, if you want to operate this resonator at 20 megahertz, like this one here, then by looking at the data sheet of the microcontroller, you have to, your power source cannot be a coin cell, a 3.3 volts coin cell. It cannot. Okay. You have to select a power source that has in between 4.5 to 5.5 volts. That means you can hook to four 1.5 batteries would be more than that, would be 6 volts. So less than that. Like if you use the USB port of your computer for getting the power, the normal USB computer, they have 500 milliamperes, so you can power a lot of things from there. This is 5 volts. So this is good for using the USB.
Okay.
Yeah, so that was the question. Correct.
One question. So now the second question was.
Why do you need the capacitor in there?
Yeah, why do you need a capacitor like this thing? Why do you need this and this?
So resistor, I understand. A capacitor, why is it there? Can you hear us?
No, yes.
Yeah, so the question was why is the capacitor there? I understand why the resistor is there, but why is the capacitor there?
Okay, these two work together. This is not necessary actually. These two things here, you can just don't put them. Okay, I'll tell you why. These two things here. Okay, I'm gonna clear this again. In here in the microcontroller, you have here the ground and the VCC pins. Okay, so this goes to 5 volts and this goes to 0 volts. This is your power source. If your power source is like this, so this is an oscilloscope now. It's like this, a steady 5 volts value. Then you don't need to put these two things. But the best thing to do that is you hook the USB to your computer and you analyze in the oscilloscope how is the 5 volts that your computer is delivering. And you will see that it's not like this. It's gonna be more something like this. You see? The problem is like, say, this is the line of 5.5 and this is the line of 4.5. Okay. The problem with this is if one of these peaks go over this. Okay, if some of these peaks go over, you are not the microcontroller is not working at 20 megahertz because there's this restriction. So you want to reduce these peaks, and you do that adding this circuit here. This circuit here makes the 5 volts, makes this signal like this, converts it to this. Not flat, but flatter.
Frank?
Yes?
Yeah, you are right about the capacitor. So the capacitor filters the noise. It stabilizes the 5 volt. But I don't think you are right about the resistor, because the resistor is for the reset pin. It's a pull-up resistor for the reset pin.
You mean this resistor here?
Yeah. That's a pull-up resistor for the reset.
But I read, you tell me if I'm right.
Yeah.
I'm gonna open this book. Do you have access to this book? I don't know how to share this book.
Video electronic components.
That's powerful.
It's not sparkful, it's independent. I have a copy of it.
Say, Frank,
Yes?
can you just open the schematic, the circuit diagram for that FTDI board, Hello World board?
There is no schematic.
Yeah, there is a circuit diagram. So the one shared in the archive, Hello FTDI 44.png.
The Cocopelli file.
Needs design page.
You mean the Cocopelli file? This one?
Yeah, it's a board file, not a schematic. Yeah, this one. So if you see that R1, yeah, one of the end is connected to VCC, other is connected to the reset pin.
Yes?
Yeah, so that vertical line that's connected to the PB3, that's a reset pin. So that's a pull-up resistor.
Yes. But it's
See, there are two resistors we use. One is pull-up and one is pull-down. So when we connect an LED, we put a resistor to limit the current, right? So that's a pull-down resistor. We connect it to ground. This is something similar, but instead of ground, we are connecting it to VCC.
okay.
So P3 will be high, normally high, and when it is activated, it goes low. So that's the purpose of that pull-up resistor.
Okay. Also, what I was telling you, like this is like a battery. This accumulating.
Yeah, that's a battery. Yeah, that's a filter.
This is accumulating those spikes.
Yes.
Accumulating this, so you don't have them. Also, let me check. Then can you tell me, Sibu? What is it? Yeah. AC. No, DC. No, capacitor. Let me see. Yeah, and you see, in here, he's also using this resistor to filter. Like the filter is the combination of these two. I think he's using both this for, he's using this for the pull-up and also for filtering. Is that correct?
Yeah, here it is correct, but the connection of the resistor in our circuit is different. It's not connected like this.
What he's saying is it is doing both the jobs, both filter as well as signal.
Yeah.
I don't think that's the point of the resistor here.
Yeah.
It's mainly for filter on the filter.
Yeah, you see, a small capacitor, typically 0.1 microfarads. So we go here and it's 1 microfarad in this case.
See, the purpose of the resistor here is to supply the PB3 pin with the 5 volt. So it keeps the PB3, the reset pin, high all the time. But we don't want a lot of current to flow into the pin, reset pin. So that's why we put a resistor over there. In ideal case, we don't have to put a resistor over there because digital circuit, in ideal case, they shouldn't consume any power. So here we need a limit. We need to limit the current. So that's why we put a 10K resistor over there. It's the same thing. When we ground a digital pin of an IC, so we use a resistor over there. We don't just connect it to ground. We use a resistor over there. So it's same.
Yeah, I mean, this is the reset pin. So the signal, this is the 5 volts. Now this signal is the 5 volt. So in here, the signal is coming from VCC. It's only, in this case, it's not doing that, okay? You are only using this capacitor.
Yeah.
For this circuit to be like this, you should have the 5 volts, the resistor in here. So you could modify this circuit to have a resistor, to have this filter.
Yeah, that's an RC filter. We don't really need that, I mean, right? Do we need that? In our circuit, we don't need an RC filter, something like this.
Well, this is the capacitor. This is what is filtering the peaks.
Yeah, the capacitor is filtering the noise in the supply voltage, not the signal. And you have shown there. Yeah, these things are for filtering the signal. This is not for supply. This is for signal.
Yeah, but in this case, the signal is our flat line 5 volts. Yeah, our signal in this case is a flat line, 5 volts flat line. This is just a circuit filter. Yeah. So this is optional, you mean? This without the resistor will make this like this?
We don't need a resistor over there. Like what we need is that resistor will limit the current. So if there are no other ways to limit the current, then we need a resistor. But since this is just a supply, power supply for the IC, we just need a capacitor filter. That's all. Maybe instead of the resistor, we can put an inductor. But we don't need resistor over there. But if we are using the filter on a signal line, then we can put a resistor over there. On a power supply, we don't use resistor for filtering because that will create a lot of. It's inefficient. It wastes a lot of power.
Okay. So if this signal, instead of being like this, is a flat line, which is what we have actually, you don't put this resistor.
No, I mean, if it is a power supply, we don't put a resistor. If it is something else,
That's
if it is like
high pass filter.
yeah, this is for signal, right?
This is low pass filter is high pass.
Yeah, this is what, that's what I'm saying. This is signal for signal. This is not for power supply.
They are using second one in our circuit.
No, he is asking whether to use something like this on a power line,
Okay.
on a VCC line. No, right? We use this on a signal line, not on VCC.
രണ്ടാമത്തെ ഹൈ പാസ് ഫിൽറ്റർ അല്ലേ അത് VCC മാത്രം
Yeah,
കടത്തില്ല
you mean
അല്ല
this is a signal.
നമ്മുടെ സർക്യൂട്ടിലെ റെസിസ്റ്റർ അല്ലേ ഫിൽറ്ററിന്റെ റെസിസ്റ്റർ അല്ല
But Shibu, this is also a signal.
ഫിൽറ്ററിന് വേണ്ടിയുള്ള റെസിസ്റ്റർ കപ്പാസിറ്റർ ആണെന്നാണ് കപ്പാസിറ്റർ AC കമ്പനി
Yes, we can do this, but the circuit will look different.
ജസ്റ്റ് പ്ലഗ് ചെയ്തതാണ്
Okay, so you were saying?
This is a signal, okay?
Yeah.
The circuit will look different.
The circuit.
You want to use it
But for me, this is also a signal, but it's flat. So in this case,
The thing is, friend, the thing is when there is a difference between like signal and a power supply. In an ideal case, a signal will not need any power. Like we don't transmit power through the signal line, so we can put in whatever the resistor we want because it doesn't take any power. But on a power line, if you put a resistor, it will waste lot of power as heat. So we don't put a resistor over the power line. Maybe we'll put it as a pull down resistor for stability or something. But what you draw over there, we don't use it on a power line. It's perfectly fine on signal line, not for power line. But yeah, you are right. I mean, 5-volt flat line is also like a signal, but flat. Then line don't transmit power.
then I actually don't understand very much why you don't put a resistor here. What is the difference? Why don't you put this?
No, I'll tell you what. So you have 5-volt. You supply 5-volt over the other end. See, left side of the resistor. Suppose you have 5-volt. Yeah.
Yeah, but this can also be, say, 5 volts.
Yeah, here you will get 5-volt as long as you draw zero current. If you are drawing zero current, you will get 5-volt over there. But the moment you start drawing current, some say like you draw 100 milliampere, so then you won't have 5-volt. There will be a drop across the resistor. Suppose the resistor is 1 ohm, then you will have 100 milliamp into 1 ohm, so that's 100 millivolts. So what you will get is a 4.9 volt on the other end. Suppose you want a higher resistor, say 1K, and you start drawing 100 milliampere, so you will have something like 1 volt. So you won't have 5-volt over the other end, you will have 4 volts. So that's why we don't put a resistor in the power line because there will be drop.
Okay, and this will not draw any current from here.
Yeah, in case of signal, it won't draw much current, so we can put a resistor over there. In fact, we don't want the signal line to draw power, so we put a current limiting resistor over there. So what you draw over there, that's perfectly fine for a signal line. There are like depending on where you put the, you saw two configuration over there, right? One the capacitor was grounded and one the resistor was grounded. That's like a low pass and high pass filters.
Mm-hmm. Okay. So understood. So this then, this is only for filtering,
Yeah.
and this is only a pull-up resistor.
Yes.
Oh, Yogi, a pull-up resistor is something you need to look into. But it's, you know, you understand what is a pull-up resistor?
Not yet, but I'll figure it out. Yeah.
Well, the short explanation is that the microcontroller can read a strong ground section. It can read a strong ground signal. It can read a strong VCC signal. But if you put the microcontroller on air, like this, like if you put the if you put it like here connected to nothing, to an air. If you connect this to ground, it can read 0 volts. The microcontroller can read here, this is 0 volts. Okay. If you put this to VCC, the microcontroller will tell you this is VCC, this is 5 volts. But if you connect the switch to nothing on the air, like, no, it's like this actually. The microcontroller doesn't know what's happened here, because this is not 0 volts. This is in the air. So you need to read something. So what you do is you put a resistor here and you hook to VCC.
Got it. So that it can read a steady volt of whatever, 5 volt or whatever.
Yeah. So the microcontroller will read, instead of this question mark, will read 5 volts now. So if you put this circuit here, when this is on the air, the microcontroller will go to VCC.
Francisco, one question: Is there a way to simulate this circuit's behavior using the the open source tools like Eagle or 123D make circuits? So that we understand the like it should like how we have for 3D modeling, something is valid, invalid. Is there a way to check, via some circuits like maybe Circuit Maker? We can simulate the circuit.
Yeah, there are some simulation tools, but I think they are quite advanced.
Yeah, I mean, I'm not referring to SPICE or the proprietary tools. Those are the scientific ones. But maybe something like Circuit Maker or even like Fritzing, which they are using for Arduino diagrams, where it's very pictorial. It's a pictorial representation, and it helps you component operation.
I think this one is the simplest one that can do the simulation.
So, for example, one way I would solve the problem if I didn't have access to software would be to, look at the connections, draw the diagram, and try and, through whole components on a breadboard. For me, that would be the only way for me to experiment and try different things.
I haven't experimented a lot with simulation, but Sibu.
Yes.
Have you tried these 1, 2, 3D circuits?
No, I haven't tried the 1, 2, 3. I haven't made a lot of other people tried here. Yadu, Nadeem, I think they have tried.
So it does come with simulation, isn't it?
Yes, simulation is the simulation is the electronics lab. There are many options: PCB design, simulation, etc., etc. The components are less. 80 tiny is 44 is not there.
You can create your own library parts
for simulation.
No, I mean, for simulation, yeah. Yeah.
Simulation, I don't know. For PCB design, we can add our own parts.
Yeah, but for simulation, you don't need an 80 tiny, maybe just any of the microcontroller. But in here it says
the tiny
85.
Tiny 44 is not there in the components. It's good for Arduino, but LVR chips are less.
44 is relatively new for most circuit design.
44 is that?
So, can anyone who has tried simulation recommend a simulation like for newbies? Would it be 1, 2, 3D or any other?
Fortius is the Fortius.
It's only for simulating Arduino, right?
Yeah. It only simulates.
Some chips are there. 328, tiny 45. Like,
Frank,
Yes.
say if I don't know about the digital or this microcontroller circuits, but if you are designing like a power circuit, like a DC-DC converter or something like that, linear technologies and Texas Instrument, they have lot of tools. I mean, TI has a very good web design suite now, so you can design, you can tweak,
actually, TA components.
and they give some simulation results like what will be the efficiency, so all sort of thing.
Problem is we can use
Are these tools for newbies?
Yeah, so I think that's one of the best tools for newbies because you just gives few numbers and yeah, they will give like uh, they have web interface. So what you do is you put your numbers, like suppose you are designing a DC-DC converter, so you just give what should be your input range, what should be your output range, what kind of power you are drawing. So then they give a lot of simulation results. So efficiency over power draw, lot of things. But the thing is, this kind of softwares are limited to their own chips. So Texas Instrument, their TI tools will have their own chips, and LT tools have their linear technology chips on it. You cannot load your own components for it. Yeah, they're limited.
It doesn't have the.
Yeah.
And Proteus is there, but it's not for Linux. It's for Windows and Mac only. Proteus. Yes.
Maybe if this is too hard, we'll have to just create our own circuit.
No, I think we'll figure it out.
Yeah.
Step by step.
I mean, it's just going to take a while to figure out. That's all.
Yeah, but I mean, for you, Yogi and Kavita, don't get stressed because you are not going to understand everything that happens in 1 week.
My main goal is to demonstrate that I have explored the options, and I want to take this opportunity also to document the failures, so that if I can't do something, this is the reason. So maybe I will complete the assignment maybe 2 weeks from now or 3 weeks from now, but at least I want to document how I thought about the process, how I'm planning to solve the problem, and whether I managed to solve the problem or not. That's my goal for this week.
Okay, but don't miss out. Just don't miss out the requirements. The requirements are these. Okay.
Yes.
You need to fabricate the board.
Yeah. Okay.
Cool. I think we're good on this. We'll take notes in case there's any other questions, and we'll pass it on. So we're good on this.
Okay. Sibu, can you post this simulation thing in here?
Links.
Yes, the simulation.
So there are no hard links like that I can share, but you just have to go to Texas Instruments website and decide what you want to do. So that's it. Just Texas Instruments website and linear technologies. So each component have their own set of design tools, and like there's one particular set of components. Say automotive components have their own simulation tools and all. And yeah, so you just have to go to the sites.
Okay. So we are going to continue. This is 7:35 now. We are going to start soon, but because we have the due day of tomorrow, we will continue we don't finish today. We will continue tomorrow at same hour.
Okay.
Okay. So Yasil just told me that he has hosted the website in another folder because Jekyll have some configuration issues. So let's check. So yes, is that like a nickname?
Is that your nickname? Yeah. Is that your nickname?
Franco? Frank.
Yes.
Francisco.
Yes. You wanted to ask something?
No, I just.
So Yasil, you use 1 through D design.
Yeah.
So you add 2 LEDs here.
One switch.
But I don't understand this one. Why are you doing this? Oh, this is the schematic.
Yeah.
You are from other pin. Why are you putting the resistor?
This is a 0 resistor.
Ah, this is a 0 ohm resistor. And this goes to.
You can see in schematics.
Yeah, the schematic is not very clear. This point here, what is that? Is VCC? Is ground?
That's
ground.
That's ground. Yeah.
Okay. Is this how it makes the schematics?
But
not very.
In 1, 2, 3 are all the components.
Oh, you can embed also? Oh, nice. Oh, it's a nice way of showing this.
Yeah.
This one 3D. So this is obviously not auto root, but you drawing, as I can see. You have to pay attention to these little details here. Like, I'm not sure if the milling bit is going to pass through here. If it doesn't pass through here, these 2 points will be connected.
Okay.
This is a common error when you do circuit design. It gives you also the bill of materials.
Yeah.
Nice. And so how do you, Jesse?
Yeah.
Jesse. You know, here, Jesse is a girl name.
I know that. Actually, I want to change it, but now I cannot update it because.
So, how do you go from here?
Okay.
Oh, so you have in this. Okay, so you have in here these 3 views. It's nice. How do you go from here? Nice. This is nice. How do you export this to a PNG? Can you export this to a PNG?
Actually,
we want the PNG.
Yeah, can you export this to a PNG?
What?
Like the circuit board, the traces.
we can export to Gerber files.
You can download Gerber files and you have to convert from Gerber files to PNG. Some of the tools.
Sorry? What are the export options?
Gerber file.
Gerber files.
Only Gerber files?
Yeah.
So the Fab modules, let let me see. The Fab modules, they don't open Gerber? No. No. They only export Gerber. Okay. So you cannot open Gerber files. Gerber files, you can only open them in Eagle, isn't it?
Yeah.
What do you do with the Gerber files? How do you do fabrication?
We can convert it to PNG files. Yeah. Online security.
Frank?
Yes?
Yeah, so there is a tool called V. That you can
Sorry. I'm having the studio from Nisha and from you. Again, please?
Nisha, you want to talk? Okay.
എൻ്റെ ഈ ചെറിയ നമ്പർ ലാൻഡ് വെച്ചിട്ട് നമ്പർ ഇപ്പോൾ അവിടുത്തെ റെസിഡൻസ് തന്നെ ഞാൻ അഡ്ജസ്റ്റ് ആവും.
Yeah. So there's a tool called jerb V in Ubuntu. Frank, you heard that?
Yes. What is the tool?
jerb V. GREB V. Okay, so that from that tool you can view the Gerber files, and then you can export it as a PNG. It has options.
Is like a command line tool?
It's not command line. It is a GUI based tool.
Sure.
So it's GRBB.
Yeah. GER.
Sorry, G?
ER.
GRBB.
E. E for elephant.
So it's Golf Echo. Oh. It's Golf Echo Romeo Bravo Victor. This. Okay. So with this, you open the Gerber file. Okay. There. And you can export this to PNG.
Yeah.
Yeah.
Okay. So this is your workflow now. Jasil, you have to export this to GRB and from GRB to PNG and then fabricate the board.
Yeah.
And start the board. Okay?
Okay.
So you have 1 day from now.
He's giving you a challenge. He's giving you a challenge. He wants you to.
Oh, okay.
Ask him what he wants you to do.
Yes?
Yeah. ആ ചെറുപള്ളി ചെയ്യുമെന്നല്ലേ? Yeah.
Okay. Jasil.
PNG ഒക്കെ നോക്കി
That one. Nothing here. Nadim. So Nadim,
അത് മാറ്റണം പ്രൊജക്റ്റ്
and this is 1, 2, 3D circuits because this is Eagle. This is an Eagle schematic.
The below one is eagle actually. You can scroll down and see.
Eagle also.
Yeah, can you please scroll down?
This is 1, 2, 3D circuits.
Yeah.
Okay, so this is the board in 1, 2, 3D.
Yes.
Circuit. Okay. Spirit level. So you are checking this.
Actually, I'm just going to. I'm planning this one spirit kind of thing with LED indicators. I'm working on schematic now. I have to route it and finish it. So.
Okay, but this is, you could use it for input devices, because this is an accelerometer. What is that?
Yes, that is an accelerometer.
Okay, so you can do this for input devices because this week it's preferable that you spend time using design tools and also you get used to mill this.
Okay.
Like, I mean, you can put this now in your input devices week and focus for this week in finishing this one and fabricating this one, because I want you to get into problems like this. You see here that this is going to be connected probably, and some other fabrication problems that are tied to design. But unless you do the milling, you will not see what is the problem. Okay, I want you to exercise the workflow from here to fabrication. You need to exercise which is the best workflow for you if you are going to use 1, 2, 3. Okay, Nadim?
Okay, I'll do it.
So, Nisha, we still have 10 minutes. Electronics design. Okay, Nisha, still not documented.
Oh, pattern now.
Wait.
What happens, Nisha? Did you? Okay. Nisha, I don't know if you are going. Do you want to tell something? Assignments. Quick book on FabAcademy. So now. Oh, it's only 2 weeks. Paul, what is Paul over there?
No.
It's getting too far. It's getting too late, Paul. Who need? Actually, why do you have this already? Machine design with the link?
No, that's probably I forgot to erase the link from that.
Okay. I have one missing image for you here. I don't know why.
I have to update it.
You started with Eagle 7.4 already. Did you import the library?
Yeah, I did.
Went through the tutorial. What is this? A plugin?
I'm sorry?
Is that Rust?
Yeah,
Rust. That's the built-in. Okay. Is that auto root or manual?
This one is auto rotate.
Is this auto root? It's doing very well.
Yeah, that is auto rotate.
Yeah, but let me check that. Isn't this very close to the LED? This trace?
Yes. So these are just demo files. So I edited them later, and these are not for production. These are just demo, like the first view you get.
Okay.
These are not for production. Like the files which I have offered to download, they have a good product and producible thing.
Then use KiCad. How is it, KiCad, compared to Eagle?
It's not very intuitive. It does almost all the job as Eagle. It doesn't have auto routing options. You have to download another tool for that. It's kind of hard as compared to Eagle, but you can do pretty much anything which you can do in Eagle. The only part I faced difficulty was finding the footprints of the things which I required. You have to either create it on your own or yeah, somebody should provide.
What does it mean?
What is that? Yeah, so that's an error which I encountered while trying to, um, I was trying to add some features.
Okay. It doesn't do auto root?
You have to download another feature for that, another software for that. It doesn't do auto rotate by itself.
Okay. Is this coming from Markdown, this document?
Yes.
Because you need to add a space here. You need to a space in between these two marks and these two V.
Right. I didn't check that, so I'll go back and check it.
Okay. So you tried fetching. This is again, you have to add a space here. Fetching is like very, very. I don't like it very much. Either. But remember, you have to fabricate one board. Apart from this, allocate, like at some point, you have to decide to stop doing that, because you have to fill the. You have to fill. You have to make it. You have to allocate time for make it.
Yeah, so I decided not to make it. I just link the Gokopelli documents and just use the FTDI created in the FreeAcademy. I don't want to do it again.
Okay. Just remember to allocate time during your week to make it and to fabricate this again. So pick one of these that you have done and actually fabricate one. Okay, because you need to do the assignment.
Yes, I understand.
Okay, we are almost on time. We will continue tomorrow with Sarat, and then now also this is the general that simulation tools. This is the one that you said. Okay. As you can see, I'm still missing your confirmation because I already fill the form. Okay, here in your instructor self-assessment. Actually, this is something that I requested to coordination, that the students, they should also have a tool for assessing the instructors.
Yeah, Frank just forwarded to the instructor.
പ്രശ്നമില്ല എനിക്ക് ഇത് മാത്രമേ രൂപ ലേറ്റില് വേണം അവിടെയാണ് ഇൻട്രസ്റ്റ് രൂപ ലേറ്റില്
Sorry, I don't hear very well. Hello.
I think she doesn't know.
Nisha is not here, I know. She logged in from somewhere else.
ഞാൻ ഒരു ആപ്പ് അയച്ചാൽ ഫോണിൽ ഇൻസ്റ്റാൾ ചെയ്യും.
Yeah, Nisha logged in from somewhere else. I don't know.
I mean, there are many people talking there. I don't.
Yeah,
whoever is talking, go closer to the microphone.
Me? Hey, Nisha is not here. Nisha logged in from somewhere else. I don't know.
Yeah. Okay. Just we continue tomorrow. Okay. Remember, many of you need a catch-up plan. Okay, but a serious catch-up plan. And some of you, I mean, like Dintis in Kochi. Dintis in Kochi is almost impossible to recover now because it has zero documentation. So if you see Dinti Zeta, you tell him that he should like show up, because otherwise, I mean, he has wasted all the money he put, because it's gonna be impossible to catch up.
I don't think he cares, right?
Tibu, you know what happens to Dinti Zeta?
Oh, Sibu is asking you a question.
Tibu, do you know what happens with Dinti Zeta?
He is busy with some of his official work. So,
but do you think he will have time to complete this, or not?
I don't know. I will get in touch with him today. So I will let you know tomorrow.
Okay, because it's too bad, because Dintis is gonna need all of these skills. I don't know why should allocate some time for doing the FabAcademy, but the more he is leaving this aside, the more time he's going to try to suck it later. So It's easy if you do it week by week. It's more difficult if you just lift. So anyway, it's late. I have to go. We continue tomorrow, same time, at 10:30, and we continue the review. Okay.
Bye.
So see you tomorrow, guys.
See you tomorrow.
Bye bye.
Sibu, ഞാനൊരു